In Chapter 9, we are dealing with solving quadratic equations. And if you recall what that means, we are solving things that look like ax squared plus bx plus c equals 0. So in 9.1 is where you're introduced to this property called the square root property. Now before I continue talking about this property, let's recall a problem that we did back in chapter 5. Okay, supposedly I were to say, can you solve x squared minus 9 equals 0? So you notice that back in chapter 5, the method we'll be using is to factor this using difference of squares. So it's x and x, 3 and 3, and then 1 plus and 1 minus. And we put each piece to 0, telling us this is minus 3, and putting this to 0, telling us this is 3. So there's two answers to this question, so there's two answers, plus and minus 3. So what you're learning today is there is an alternative way to do this. So alternatively, we could solve using the square root property. And what this property says is this: if x squared equal a number and that number is non-negative, then x is equal to square root of it, but plus and minus. So basically it's saying that there's two possibilities. Okay, so let's try this as our first example. So can you solve x squared minus 9 equals 0? Now, in order for you to apply the square root property, the square term has to be isolated. So that means I have to bring the 9 over first. And then three things going to appear when I get rid of the square. The square is going to go over as square root, but at the same time there's going to be a plus and there's going to be a minus. So there's really two answers to this. So it's not hard for us to understand this because what it's asking is when we square something, what's the number, what's the possibilities? So in answer to it is telling us that there's really two possibilities. It could be the positive 3 or it could be the negative 3, where if you square you get the same answer, 9. Okay, and if you look above, you notice that we also got the answer plus minus 3 using factoring. Okay, so square root property is the fastest way to solve a problem. The only thing is you have to look like perfect square on one side and a number on the other side. So it's very restricted in terms of format. It has to look like a perfect square. So let's do a whole bunch of examples. This example 2. Supposedly I say, can you solve, let's try y squared minus 2 equals 18, for example. So square term has to be alone, so bring it over. So it's 18 plus 2, which means y squared equals 20. So y is equals to plus minus square root 20. So three things has to appear: plus, minus, and square root. So y is equals to plus minus 20. You have to break it down as 4 and 5. So your final answer is plus minus 2 radical 5. Okay, so let's call this example 3. Supposedly I say, can you solve say 4x squared plus 25 equals 0. Now what's going to happen is you have to bring the square term alone, so you're going to bring 25 over as minus, and you're going to divide both sides by 4, making the x squared equals negative 25 over 4. So the next thing that's going to happen is you're going to take square root of negative 25 over 4 and plus and minus. Now this is the part I hope you remember. When you try to square a negative number, this is non-real. Okay, meaning it's a complex number. So the answer to this question is you have to say no real solution. So bear in mind that there is a solution, except that it's not a real one. Okay, so we say it's no real solution. Okay, so let's continue with more examples. Let's call this example 4. So what if now I were to say, can you solve 5x plus 1 squared minus 7 equals 13? Now, back in chapter 5, what we would have done is to FOIL, okay, and then combine like terms and so on. But now you don't have to, because you notice that this is tucked away nicely in the parentheses with a square on the outside. So it does kind of fit the mold that we're looking for. So all you have to do is to isolate the term with the square, and then at the same time you're going to bring the square over. So leave the 5x plus 1 in the parentheses and bring the square over. Three things going to happen: the square root, and then the plus and the minus. So what you have is 5x plus 1 is equals to plus minus. This is really root 4 times 5, so it's going to be 2 radical 5. Okay, so let's finish the story. Now my job is to look for x. So what I'm going to do next is to bring the 1 over. So it's minus 1 plus minus 2 radical 5. And then the next step is to divide throughout by 5. So my final answer to this question is minus 1 plus minus 2 radical 5 all over 5. Okay, let's go for example 5. Can you solve 25x minus 3 squared minus 7 equals 0? So remember the rule of the game. For you to use the square root property, the square term has to be alone. So anything in the parentheses you can treat it as 1. So focusing on keeping that alone, I'm going to bring the 7 over first. So it's 25x minus 3 squared equals 7. And then I'm going to divide both sides by 25, leaving me with x minus 3 squared equals 7 over 25. Okay, so I want to keep it in the parentheses, but I'm going to get rid of the square. So when I get rid of the square, it's going to go over the other side as three things. It's going to be square root and then plus and minus. Okay, three things going to appear. And what you have is plus minus root 7 over root 25. So what I have in the next line is x minus 3 equals plus minus root 7 over 5. Okay, so let's continue. I'm trying to get x alone, so it's going to be 3 plus minus root 7 over 5. Now if you look at this problem, you notice that your answer is still in two pieces. We want our answer to have one single fraction bar, so shared fraction bar. And in order for you to share one fraction bar, I need to have both of you have the same denominator. Okay, so right now 3 is really 3 over 1. So I'm going to times 5 top and bottom, making you a 15 over 5 plus minus root 7 over 5. So if you look at these two now, they have the same denominator. Okay, and once the denominators are the same, you can write it one time and then put both of these pieces in the numerator, and then you're done. Okay, let's see one last example, and then after that you have to practice. Okay, so let's call this example 6. Can you solve 50x plus 3 all squared minus 72 equals 0? Remember, keep that alone. Okay, so the term with the perfect square has to be isolated. So 50x plus 3 squared equals 72. And then x plus 3 all squared is 72 over 50. Now this is something you should always remember. Reduce first. Okay, so before you bring the square over, let's clean this up a little bit. You notice you can divide both these numbers by 2, which reduces to 36 and 25. So 36 over 25. Okay, so now I'm going to take the square root. But at the same time, when the square root appears, is plus and minus. Okay, so what I have is x plus 3 is plus and minus 6 over 5. So what I'm going to do next is to bring the 3 over. So it's minus 3 plus minus 6 over 5. I want a common denominator, so I'm going to times 5 top and bottom, which makes this a negative 15 over 5 plus minus 6 over 5. Now both of these are rational numbers, so even if you share a common denominator, you're looking at two rational numbers which you really should further combine. So minus 15 plus 6 all over 5 is one possibility, which gives you the negative 9 over 5 as the answer. And negative 15 minus 6 all over 5 gives you the other possibility. So for this question, there are two answers. It's going to be negative 9 over 5 and negative 21 over 5. So the problems in for 9.1 is found on page 400. So try some problems on page 400, 401. Okay, so try those and let's move on to 9.2.